Good morning, 8th grade. Welcome to week 5. I hope you guys had a nice, easy week last week. I'm going to take you through what you need to do today to be successful. Today is April 20th, Monday, and we are starting our week 5 of remote learning. So you're going to click on your classwork tab. You'll notice I put up an agenda for week 5 if you want to use that just as a guideline for what you'll be expected to do each day this week. You're going to scroll down to week 5, day 1. You'll see your lesson here. Today's lesson is reviewing systems of equations by graphing. So you guys should already be familiar with this. We just wanted to give you a quick review so that everyone remembered. So the warm-up goes over what a solution is to a system of equation, and a solution is going to be the ordered pair that is a solution to both equations. So if you remember when we were in class and we started this lesson, we went over when given a point and they ask you, is it a solution? You take that point, so this one was 4, 3, and you plug it in to the two equations. So x would become 4 and 3 would become y, and you check it in the equation to make sure the equation comes out true. Remember, in order to be a solution, it has to work for both equations. So you'll see I then tried in the second equation to make sure that the solution also works, which it does. So since it works in both equations, we can say yes, 4, 3 is a solution to this equation. Okay, 4, 3 would be a point that these two lines would intersect at because they share that common solution. Okay, so then we just give you another one to practice. So I'll walk you through that one here. So they want to know, is negative 2, 3 a solution to the system y equals 2x plus 3 and y equals 4x minus 8? So all you're going to do, let me see if I can get my other marker to work so that I can show you color-coded. Okay, so we're going to take our x, which is negative 2, and our y, which is 3, and plug it in. So instead of writing y, I'm going to put 3 and then equals 2 times, I'm not going to put x anymore, I'm going to replace it with what x is, negative 2, and then add 3. Now if this is a solution, then this equation should come out true. So let's see. We have 3 equals 2 times negative 2 is negative 4 plus 3. And then we have 3 equals negative 4 plus 3 would be negative 1. So this is showing that this solution is not a solution to this equation because the equation does not come out true. So this is a false statement. So we would say no. Okay? Usually that's where you can stop because we need to make sure that they work for both, and if it doesn't work for one, then you can assume it's not a solution. But I will show you the other equation just so that you can check your own work, okay? So we have y equals 4x minus 8. So y was 3, so I'm going to replace y with 3 equals 4. Instead of x, we're going to replace that with negative 2. So 4 times negative 2. And then we have minus 8, right? So we do that calculation. We get 3 equals 4 times negative 2 is negative 8 minus 8. And then we would have 3 equals negative 8 minus 8 would give us negative 16. So again, this solution doesn't work for this equation. So this is a no. Okay, so our final answer would be no, negative 2, 3 is not a solution to this system. And if you scroll down in your lesson, you'll see that work here as well. Okay, then we go over graphing. So this lesson really is just a review. You guys should remember this from school. We were working on this. This was like our week before we stopped meeting in the classroom. So, you know, I'm going to model one example, but the rest of them you guys should be good on your own. So they're going to give you a system. Our system is y equals 4x plus 3 and y equals negative x minus 2. In order to solve using the graphing method, you're going to graph one equation at a time. So we're going to focus on this equation first, and the best thing to do is to identify the m and the b. So remember, m is always going to be the number that's next to x. So our slope in this equation is going to be 4, and our b is always a number by itself, so that's going to be 3. If we think about this on a graph, we know that we're going to move 4 units up and 1 unit to the right, because remember, we could always put a whole number over 1, and we're going to begin at 0, 3, because b is our y-intercept. Any coordinate that's on the y-axis will always have an x value of 3. So I'm going to graph that for us. So I'm just going to write to the side. We're graphing y equals 4x plus 3. Okay, so I'm going to begin my graph at 0, 3, 1, 2, 3. I make a point. And then we're going to move, since it's positive 4, we go up 4, and we always run to the right 1. Okay, so from here, I'm going to count up 1, 2, 3, 4, and then run to the right 1. Okay, now my graph doesn't allow me to go any further. Your graph might allow you to go further, but if that's the case, then we just reverse what we did. Instead of going up 4 to the right 1, we're going to go down 4 to the left 1. Okay, so from here, I'm going to count 1, 2, 3, 4 to the left 1, just to reverse and extend my line the opposite way. Down 4, 1, 2, 3, 4 to the left 1. I think I could fit one more. 1, 2, 3, 4 to the left 1. Okay, once you have all your points plotted, you usually use a straight edge. I only have 2 hands, so I can only just do my best. All right, put arrows at the end of your line, and then remember, we always want to put the equation somewhere near the line to label it. Okay, so there's my first line. I'm going to go to the second line. So the second line is y equals negative x minus 2. So again, you want to identify your slope and your y-intercept. So in this case, the number next to x, even though it's not there, we know that would be negative 1. And as a slope, we would move down 1 to the right 1, because a negative slope means our line is going in the downwards direction. And our b is negative 2. Written as a coordinate, that would be 0, negative 2 we would begin at, and again, we'd be moving down 1 and to the right 1. So I have that equation written here. Remember, we're going to put a 1 in front of this x since we know it's there. And since it's a negative, we're going to be going down 1 to the right 1, and we're going to start at negative 2 on the y. So I go to my y-axis, I'm going to go down to negative 2, make a point. Ooh, my red's becoming black. Okay, and then we're going to go down 1 to the right 1. Down 1 to the right 1. Down 1 to the right 1. Notice we're forming a negative slope, which is exactly what we wanted. That's what our equation said. And once I extended this way, I'm not seeing any kind of intersection between the lines, so I know I have to reverse and extend in the opposite direction. Once I do that, I should see an intersecting point, which will be our solution. So instead of going down 1 to the right 1, we're just going to reverse it. We're going to go up 1 to the left 1, up 1 to the left 1. So I'm going to start here, up 1 to the left 1. I think we just found our solution. Up 1 to the left 1, up 1 to the left 1, and so on. Okay, you connect your line, put arrows. Okay, I'm going to write my equation. And then remember, we always like to circle the point that is our solution to make it known that that is the point we are focusing on. And then I usually have you write that solution here. So the solution would be, this point would be negative 1, negative 1. Because if this is 0, then we're at negative 1. I'm sorry, I wasn't on the graph. It would be negative 1, negative 1. That's where this point falls. Okay? All right, and then you'll see that in your lesson as well. If you keep scrolling, I take you through each step, okay, and see we have one solution. Anytime lines intersect, there is one solution, and that solution is the ordered pair that those two lines intersect at, okay? The rest of the lesson has you try others, same idea. And then there's the you do. So this is in your Google Classroom. This is your classwork assignment for the day. So I'm going to X out of this to show you where you can find that. Okay, So you're going to go here, the UDO Extra Practice. I gave you the different options to complete this. I know some of you do have a printer, which I think is the easiest thing. If you just print out the document, graph your systems, there's only 2 of them, and then send me a picture of your work. If you don't have access to a printer, you can easily make these graphs on your own, kind of like how I did on here. I know most of you won't have a whiteboard at home, but you should have paper where you can create your own graphs. And this would be perfectly acceptable. Just create your own graphs, graph the systems that are provided, and then take a picture and upload your work, okay? You can also send me a picture through texting the Google Classroom phone number, through PupilPath, through my email address, through Instagram. So there are plenty of ways to get this assignment done. I expect all of you to do so. This assignment is to assess your understanding of graphing, so you may not use the Desmos website for this assignment. Okay, I don't want to see Desmos for this. I want to see you guys graphing it on your own. So here's the assignment. You would click on it, and you'll see that you're going to have 2 systems to graph, okay? You'll tell me like what the lines are they intersecting, are they parallel, etc., and then you'll identify what that solution is. All right, and then once you're done with that, you have a quick exit ticket, which is just a Google form going over what we did in the entire lesson. So checking if the point is a solution, like we did in the beginning, and then identifying the solutions of the graphs provided. And that's it, okay? I hope this helped, and I will talk to you guys soon. Take care.